All right, lecture 2, why database? And there are a couple different ways that we can view this as a why, but the first one I'm going to talk about is how most applications today are built. You have somebody over here on a computer with a keyboard. They've got some sort of little application, okay? They've got a keyboard and a mouse. That little guy connects to a router, okay, in some fashion. Probably connects to about 14 of them, but we're going to call this thing in between the cloud frame. And out of that cloud frame, when they type in www.washingtonpost.com, and I'm going to argue that Washington Post is an application. It's a very complex application that's designed by the Washington Post for presenting the news. But it's no different than, say, the banner registration system. And the first thing that they're going to do is get a DNS address. They're going to use DNS to turn that Washington Post into a number, like 12.2.41.3. That, by the way, is not the Washington Post number, but it's an IP address, or an IP version 6. This is a version 4 or a version 6 address. Version 6 addresses are longer. And then the data is going to propagate back through the cloud frame to them, and they're going to go out again to the router, back into the cloud frame, back out to some server farm. Okay? And that server farm is going to say, okay, at this address, they wanted something called /, which they're going to map into index.html. And index.html is going to be some sort of a file, usually, but not always. It could actually be a piece of software that's going to send some data back that looks like a file. In the case of the Washington Post, that is in fact the case. It's going to be a program, and that program is going to send back some information. And that information is going to propagate through the frame cloud back to this, and it's going to have a whole bunch of things in it. But every one of those things in it is going to get parsed out and processed through this kind of a path. And on any particular day that you bring up the Washington Post, every time it does this, it's going to say, for this index.html path, I'm going to go out to a database, and I'm going to pull out some information, like what is the top headline? Okay, what are the pieces for the page? What goes in the opinion section? Who are the top authors? And every time one of these stories changes, it goes out and updates the database to make the changes to what gets presented. And in this application, the database is where it stores all the information about how it's going to present this information to the person. Now, part of what you see when you bring up the Washington Post is it's also going to send some special header information that tells them, have you subscribed to the Washington Post? There's some security information. So there's user information and passwords and authentication keys, all of which are stored over here in some kind of a thing called a database, whatever that is. But if you look at applications today of all sorts, generally speaking, okay, most of them, this is how they're built. We've got a web front end that sits over here. That's this piece on the web. We've got a whole bunch of routing stuff in between. We've got an application server that is here. That's this piece. And we've got a database. And that's this piece over here. And yeah, there may be other pieces in between. Instead of one application server, we may have a proxy that routes between multiple application servers because it's something like the Washington Post and they get a lot of requests. In fact, if it's something like Google, those proxies may actually be hardware proxies that cost millions and millions of dollars each. And there may be hundreds of thousands of servers here in the server farm. But the basic principle of it's a web page, there's an app server, there's a database. Now, you go to some applications like Discord or the desktop Slack application. And what do? They build it as a web page. They put the application server on your computer so you don't run through the internet here, and then the application server goes out to the internet and talks to the database. And that gives you a desktop application. The primary way of doing this is a thing called Electron, although you also see React Native desktop applications. That's how Facebook's application for their desktop is written. And you see things running on smartphones, on tablets, in iOS, in Android. And an awful lot of them are written with things like, instead of a web page, they're actually written in a native programming language. And they use the same protocol to talk to a server. And the server talks to the database. But increasingly, you're seeing an awful lot of those written in things like React Native. Or Flutter is a good example. It's one of the most quickly growing up-and-coming mobile technologies. And Flutter is basically a web page with style sheets, done in a nice way, built into a language, and it runs on there. It talks over the web to an application server to a database. Now, what's this magical thing, a database? A database is a collection of pieces of data. And there are a number of different ways in which we've done that. Most data that is structured in the world today is not in a database. It's in Excel. Most interactive data that is shared is in a thing called SQL, standard query language databases. But there is also a set of databases out there that we call NoSQL. Okay. Facebook uses a database that they developed themselves called Cassandra that is NoSQL. The most common one, well, Cassandra is really big scale. I have actually brought that up on servers that I have. Realistically, to get it up and working, you need a minimum of 15 computers, which means this is not your home application. They run it on a few million computers continuously, all at once. That's not the only big-scale database. But the most common, smaller NoSQL database is a thing called MongoDB, for which I have very little love, but we're going to do some stuff with MongoDB in this class as well. And there are other NoSQL databases. I particularly like one called Redis. Redis is an in-memory data structure and caching database, and it works really, really well with SQL databases for lots of things. I worked for a company in Utah that does customized pre-programmed searches for businesses. Basically, if you're a business and you want a Google search on anything that's published about you, you go to this company, you pay them $30 a month, and they say, okay, today's stuff that you got on the web, all the PR, good news, bad news about you, is this list. And you get it every day. So it's not terribly expensive, and lots of companies buy this service from them. But this means that that company basically indexes the entire web just like Oracle, and they scrape the entire web looking for this information. Now they've got all of these different scrapers out here across the web, and they all feed into, yes, a Redis database. So millions and millions of entries go into a Redis database, come out and end up indexed and processed. There's a program out here. And it ends up in a Postgres database, actually a set of Postgres databases for doing the indexing. But there is this big Redis database in between that is a giant queue and buffer between the front end collecting data and the program that processes the data and the end result in a SQL database. So, yeah, Redis is useful. We're going to touch some stuff on Redis. It's an easy to use thing, and it has a nice place. MongoDB is supposedly a NoSQL document database. We're actually going to take a look at MongoDB from the perspective of everything that you can do in MongoDB, you can do in Postgres better and faster. So that's going to be our perspective on Mongo. Now, SQL, where did that come from? Some years ago, there was a project that was done by IBM for the United States government for an organization called NASA who wanted to put men on the moon. And part of that project was they built this new thing no one had ever built before, which was a single place to store all the accounting information and all the budget information for these Saturn V rockets. And they built a thing called a database. And it wasn't a SQL database, but out of that research and that contract that they built for the government, they decided to come up with a standardized format for querying data. At the time, there was a format for accessing data called PIC. And I've used PIC. It's not really around much anymore, but it was useful. But they got together, made a standard committee, and they standardized this thing called SQL, SQL, or Standard Query Language. And it is a descendant of PIC, and it's a standard. And IBM built a couple databases, both called DB2. One of them is DB2 mainframe, the other was DB2 Universal that does this. Most banks are running on top of it to this day. And one of the people that helped standardize this, a guy by the name of Larry Ellison, split off and built his own company. Actually, he bought a company, he quit doing what they were doing, had their developers work on this Oracle SQL. And it is the most common SQL database in the world today. Now, there are other SQL databases like SQLite, MySQL, which is pretty common. If you're looking at the New York Times, it's running on MySQL. So there's a bunch of them, okay? And if you look at the development rate in different databases, okay, lots of them don't have much changes. This is a standard that's been around for a long time. The exception to that is this one called Postgres. And it's getting increasing adoption over time, and more and more people are using it. It's got more features. It's got lots of things that have been going on with it. So it's the one that we're going to look at. It is free and open source. It's very reliable. It's scalable. And because it is open source, some people have used it to build the world's first world-scale database. A group at Google has created the F1 database. F1, if you've ever used Gmail or a Google product, the data is stored in this F1 database. And it runs in 14 data centers. I asked a friend that works at Google roughly how many computers it runs on, and he thinks it runs on around 14 million computers simultaneously. One single database. In real time. So that it's sufficiently real time that when they went to do the monitoring cameras for security inside the Google data centers, instead of building a new application, they simply fed the video into a table in F1, and then it becomes available to their entire organization for people that can access that table. Real time. Around the world. Anywhere they want to have somebody access it. So that is a Postgres derivative, as is some other stuff that has been built around this, one in particular, which is a open source clone of F1, not clone, an open source implementation of F1 called CockroachDB. So this is SQL. Now, what is SQL, and what is a database, and how are tables put together?